Hey guys, so I'll show you what we got so far here. This is the input section. This is the three 12 kilovolt at 30 milliamp NSTs in parallel, so we effectively have 12K at 90 milliamp. This is my poor man's Terry filter. I use these variable potentiometers here I got from old ham radio auctions parts, and I made a little three-way spark gap here for it, so this is actually hooked to ground, just like Terry filter design. These act as a variable resistor, but also as a variable inductive choke, so I can actually change the slider and affect the inductance on them. There's two approximately 1 nanofarad capacitors. You know, I figure why waste all the time with chaining all them little guys together that are rated at 2 or 3 kilovolts to protect yourself from up to 20 kilovolt, whatever. You know, I can use two Leyden jars at 1 nanofarad and still get a pretty good size filtration going on. So these are my two main outputs for the AC after the filtering. I've got two MOT diodes in series in a full bridge rectifier configuration here. That's my light. And so from there, we're charging the Leyden jar banks. You can see I've got probably about 23, 24-ish nanofarads going on there. And this guy's not hooked up anymore because he seems pretty much worthless now that we have these. So sometimes I add him to get a little three more or so, whatever. This is the main spark gap that directly shorts. Gotta stop holding my finger over the camera. That directly shorts the bank. And from there we have now we have the series setup. So I'm going through a microwave transformer or a capacitor here that is 0.63 microfarads at 2100 volts. So it's way underrated for the amount of power. And I have noticed it getting a little hot, so I know its lifespan is limited, like everything. All things in time must pass. Anyway, we're going into the shitty-ass primary here that's undersized. It's only about 15 inches inner diameter. It should be 20. So I've got plans to rebuild that, but I wanted to get my driving circuit worked out better before I spend all the money on the copper. I'm looking at probably maybe a 2-inch copper strip that I'm going to wrap in pancake format in the center for the bipolar config. But for now, I've got this tuned a little better for just unipolar configuration, so this half isn't really being used. This side is hooked to earth ground, as you see down there, so that's running down to the ground rod. And I've only got 3 shitty-ass wraps here. There's other 3 more that aren't hooked up because the pipe's not connected, because I was dumb and cut it for some other stupid reason. So I'll probably hook them back together or something. I'm not sure what material I'm going to use yet for the primary. But anyway, it's about 600 wraps, I think, from what I gather on this. About 40 per inch. It's 46 inches long, not counting the inch or two at the either end. So what I'll show you is that when I crank it up, we're going to see this traditional series reactance style effect going on where that capacitor charges up in a DC polarity, and then the spark gap that shorts the bank is going to arc over, and that's going to in turn cause the oscillation to happen in the tank circuit that has now become isolated from the source circuit. And just for those 3 wraps, you're going to see a massive inrush of current being induced into the secondary, and we'll see some pretty good arcs come off of the far end over there. So let me fire it up. It's going to be loud. It only fires once every few seconds by the time that charges up, but I can at least show you the arcs before anything catastrophic happens. So I'm going to bring the voltage up a little bit. I'm going to get to the point where it starts to arc over. I'm running about 40 volts into the NST, so it's not even that full blast. So you can see we get a little bit of, there's a second gap in series there. Oops. So here's what we look like for output. Really good, strong white arcs coming off of there. So it doesn't even need full voltage from the NSTs. They're very underrated right now. You can see I got, that's my voltage coming off there, but I even get a little bit of an arc off of the primary when it happens. If there's plenty of voltage going here, I'm reluctant to let this arc because my nice lacquer job is becoming compromised. But it's really interesting for that 0.63 microfarad. Giving it more voltage obviously makes it fire a little faster. Let me shut it off so you can hear me. Makes it fire a little faster, but it still doesn't increase the output, which is interesting. Maybe that's just because of the limit of the capacitor. It's only able to charge so much, and then the only thing that changes is the actual VCO, or voltage controlled oscillation time, from the spark gap breakdown. So it's good progress, I think, on it. Get really good output, and I hope that I can build a better primary. It should really be 20 inches inner diameter to be tuned to 1/2 wavelength of this secondary here. I originally intended this to run in bipolar configuration, so it would be exactly in the center, but given the output, the tuning, I'm starting to wonder if I didn't quite make it long enough for bipolar config. It could perhaps have been a couple inches longer given the diameter, because we're only looking at about a 2.5 ratio. It's 10 inches diameter, and then in direct center I would probably have 24 inches on either side, so I'm probably 2.5, or I should have been more like 3.5. So by moving this over to the right, I shifted back towards unipolar configuration, to where this isn't really used as much, even though it is overloading it a bit with a more of an inductance towards the bottom. But the amplification is obviously better because the wave is able to traverse the secondary, the length of the secondary, not necessarily the length of the wire. The length of the secondary is what dictates the wavelength tuning. So ultimately I'm going to try to set this up like the sieved apparatus, where we can run a ground wire off of it and be able to see the actual voltage wave forming, perhaps, when it's hooked up to AC. But for now, I just wanted to show you that this is the DC configuration with this series reactance bank effect going on here. And while I'm not exactly happy about using DC to drive this, it does have much more interesting results as it has so far with my AC. Obviously, when I was doing the hairpin d'Arc ball setup, where I had 12 nanofarads in series on either side, and it either had not enough power going in or whatever, but the voltage was, or the output was extremely minimal. You know, I was not getting any induction at all going on. Very tiny little arcs. So I kind of stepped back before I, build any more on that to try to figure out what actually might be going on. So now I'm going to start to work on constructing a better form for my new primary and figure out what kind of copper I'm going to use. And I think once that's done, the output of this thing is going to be ridiculous. Thanks for watching.